Hello class, Professor Anderson here. Let's say we're trying to figure out what V is if we're given E, and we want to sort of have a graphical interpretation of this. Okay, and let's pretend that we have the following. Let's say that our electric field, which is in the x direction, as a function of x, looks like this. Okay, it grows linearly in x. And we can give it some value. We'll say that E is equal to 500 times x. And this is the x component of E. So E is everywhere pointing in the x direction, and it has this value that is increasing as a function of x. All right. How do we figure out what the potential is? Specifically, let's figure out what V at 0 is compared to V at position x. All right, we can probably do that. Let's give this a different value. We'll call it x sub a. All right, how do we do this? Well, what we said last time was that the potential V is related to E through an integral. In this case, it's all one-dimensional, so we can just write this as dx. And there is a negative sign out in front. The dot product here just picks out the x component of E, and so this whole thing just simplifies to that. Okay, integral of ex dx, and we have to integrate between our 2 points, 0 and x sub a. Okay, but this is our electric field. So we have the integral 0 to xa of 500x dx. And now we know how to integrate that. 500 is just a number. If I integrate x, I get x squared over 2. And so we end up with negative 500 x squared over 2. And then we have to evaluate this thing from 0 to xa. And so we plug in xa, and we just get negative 500 xa squared over 2. And when we plug in 0, obviously, we would get 0. Okay, so this is delta V, specifically. It's the potential difference between xa and 0. And what it says is it's a negative number. That should make sense to you, because if the electric field is pointing in the x direction, that means you have to have higher potential on the left side, lower potential on the right side, just like you had charged plates here. Positive on the left side, negative on the right side, and that's why this delta V, in fact, goes down. Okay, but we said we were going to look at this thing graphically, right? We did a bunch of math. What do we mean graphically? Well, integral is, of course, equal to areas. Specifically, it's the area under the curve. So by doing this integral, all I really did was I calculated this area right here. Is that really that area? Should we just double check? Sure, why not? If this thing is going up as 500x, then this value right here is 500 x sub a. We know what the area of a triangle is. It's 1/2 the base times the height. The base is x sub a. The height is 500 x sub a. And we, in fact, get exactly what we got over there, 500 x sub a squared over 2. The area is that, but that negative sign means you got to put a negative sign out in front of there. And so what we really want is the negative area. And now everything matches up. Okay? All right, hopefully that's clear. Cheers.